Hello, this morning we are going to do a quick overview of some new NMR permeability logs that we've added to UTAP wells and show you how to use those in conjunction with some fluid substitution. To do that, I've created a simple synthetic model here. We have a water oil contact down at the bottom, some variation in the water saturation over these layers, some irreducible water saturation. Here you can see a variation in the porosity and the permeability. So what we're going to do now is we'll open the NMR Studio from that button, and we're going to run the NMR in the Earth model on this to get eventually a T2 distribution for each of the layers that you see here. And so in this case, we're just going to use the time domain with this sequence here, which I've modified a little bit. And I've also made a modification to the NMR rock class using the default class with a bimodal distribution centered at 2 and 10. And now I'm going to run the calculate. And so now it will calculate, this calculates a decay curve for each of these layers. And after that's calculated, then we'll run an inversion on those in order to get the T2 distribution. So now we have CPMG decay curves calculated for each of those. Here I'm selecting Earth model. I'm set a fixed regularization range of 3. And now I'm going to invert this. And this will put into each layer in the data a T2 distribution. And additionally, this will also calculate the NMR porosity for each layer and the T2 log mean for each layer. So log mean is a new one that we've added here, which is now available directly from the Earth model. And so I'll show you that. As soon as this is done, we can plot that because now we already have these in the Earth model. So before we move on, notice that up here, we still do not have anything, any logs or any NMR data in this well, which is the demo NMR logs. But just from the Earth model, we can go ahead and plot make an NMR plot here, and Earth model distributions time domain formation T2. Okay, so we have that here. We want to plot this in the usual logarithmic. We'll go from 0.3 to 3000. Turn off that border, and then we just have to increase the size a little bit. Okay, so now we can see all these. Okay, so there you see the NMR T2 distributions that we just calculated, and you can see that there's one per layer, and we have layers of different sizes. And but additionally now, a new thing that we've added is that we can also plot NMR T2 log mean. And so now let's make this a little bit bigger. And so now you can see that this corresponds to the T2 distributions that we've calculated here. All right, so now what we want to do is, and if you wanted to, I'll just show this. We can also, in the porosity, we have an NMR porosity available too. We've had this before, so it's not really something new, but I'll just show this to you. I'm gonna make it a dotted, just so it shows up. Whoops, didn't mean to do that. Make this Earth model total porosity for the top one. All right, so there you can see that we have the NMR porosity on top of the Earth model total porosity. And so the NMR porosity was actually calculated from the T2 calculation. All right, so now what we're going to do is eventually we want to get here to the NMR log sets. And we want to calculate some new things that we have, which are the Teamer-Coates permeability and the SDR permeability. But to do that, first we need, these operate on source data, NMR data. And so we need to get an NMR data set here, which we can either get from importing NMR data or from doing a simulation. So in this case, we're going to do a simulation, and we have time domain data. We're going to simulate based on the relaxivity calculations done with that. And I'm going to call this, because we still have hydrocarbon in the Earth model, I'm going to say, call this with hydrocarbon. And then we'll just run this simulation. And so that's done. And now you can see up here that we have NMR simulation with T2 and the NMR porosity in there. So next we're going to run these NMR logs. And so now you see that already the NMR simulation with hydrocarbon shows up here. So we're going to select that. We'll go ahead and process all the ones that we're interested in. And first, I want to show that for the Teamer-Coates, you have the parameters to set. We're using a default 33 milliseconds for the T2 cutoff, which is fairly standard for sands, clean sands. And a parameter is C of T, and where those fit in, if you click on this, this tells you what the equation looks like and a little bit about the parameters. And basically, we have it takes the T2 and the T2 cutoff and calculates the free fluid over bound fluid ratio, along with the total NMR porosity and the constant that you select, and then calculates this permeability here. So we're going to select that, and then up above we have the SDR permeability. Now that works on, again, you can see what it takes to make it work, and the permeability is some constant times the T2 log mean to some power times the NMR porosity to some power. And so these three constants you can see are available up here that you can change if you need to for different situations. I'm going to leave them at the defaults. But the thing to notice is that you have to have a T2 log mean, which you have to get from somewhere, or and a NMR porosity. So because now we have both of these available in the Earth model, for this first run, I'm going to use the Earth model properties. So we have the T2 LM time domain, which is what we just calculated. And then we have the NMR porosity in the Earth model. So now that means that you don't have to pick, you could also pick simulated logs or imported logs if you have that. So now, and over here, I'm going to customize this. Oh, and so I'm going to say that this is we'll make a log set with hydrocarbon. And I'm going to call this the Earth model one. All right, so now we create the log sets. And now it's showing you which ones it's creating. And as it creates those, you'll see these show up here. And now you can see that we have all 4 of these logs that we had checked here. And the one thing that I want to show about, most of these are self-explanatory, but the one that I want to show especially is the Teamer-Coates permeability. Because this operates on calculating various integrations of the T2 curve, we not only get the TC permeability, but we also get the bound fluid fraction shown here, which is the fraction up to the NMR, up to the T2 cutoff. We have the T2 cutoff down here, which you can plot, which we will show you that you can plot. So it shows you where the cutoff is on your plot. And then you also have the full NMR porosity here, which is calculated, which is just the used in this equation, but it's the full integration of the T2 curves. And so you can use these. In this case, we did it on the Earth model, but you can also use it on any imported T2s that you get. And then notice that in the SDR right now, we just have the SDR Earth model permeability that we calculated. But now that we have these simulated logs, I'll just show you that you can also now select a simulated log. And in the T2 log mean, we have a simulated T2 log mean, so you can either use a simulated or a imported log. And then for this, we have you can either use the NMR permeability, or we'll use in this case, the permeability that we calculated with the T2 NMR, TC NMR. And in this one, I'm going to change, I'll put it in the same hydrocarbon log set, but I'm going to call this one sim. So that way we can distinguish them. And so now if I calculate that, you'll see that in here we now have Earth model and a sim, so we can compare those and see that they are fairly close. All right, so now let's go here and plot some of these. So in the T2 distribution, I'm just going to label this T2. We want to add the T2 cutoff. So that's going to be a simulated log. T2 cutoff is found in the TC log set, and it's down at the bottom here. And let's make that, okay, it's showing up as green, so we'll make it even a little bit bigger just to make it very clear where that is, and maybe make it a little bit lighter. Okay, so there's the T2 cutoff that we used. So you can see what you might expect from that. And then we can also plot, because we plotted the Earth model T2LM, and I can just show you that since this is also calculated from the Earth model, these should be pretty close. I mean, the only difference would be the simulation effects. And so let's do simulated T2 log mean, and make this dotted or dashed. That's what we usually use for sims. And then I'll move this up above this red one. So there you can see that this pretty well matches the expected Earth model version of it. And then we're going to go over here and we'll plot the porosities. So let's go to, or the permeability, sorry. So we have the Earth model permeability. So now we want to plot some of these simulated permeabilities from the NMR. And so the first one we'll plot is the T2, or the TC NMR, the Tumor-Coates NMR permeability. So we can see that here. Then we will plot also, let's see, this is, I'm going to make this dashed because simulated. And then we'll also plot the SDR permeability. And here we have two of them. We have the Earth model or the sim. So we'll plot both of these. We'll plot right now this is the Earth model, and then we'll plot another one, which will select the sim, and I'll make that dash dot so we can separate those. And you can see those are pretty much on top of each other as well, but both of these are off the Earth model. And so you probably know why these are off the Earth model, because we have this hydrocarbon in here. And so what we want to do is we want to get rid of that hydrocarbon. And I'm going to show you that in UTEP wells. That's very easy to do. We'll do a fluid substitution. So I'm going to make a duplicate well. And I'm going to rename this, say, W on the end. We're going to start putting W on the end of everything. And so I'll leave this one open, but just put it down at the bottom. We may want to compare later. Then we'll open this one. It should look the same. Okay, but now what we want to do is we're going to go in here where we have the populate properties, and we are going to select for zone 2 total water saturation. And we're going to use an explicit value of 1. So we're just setting this to be, we're replacing all the hydrocarbon with 100% water. Hit populate. Now watch here, you have here you see the current water saturation distribution. And when we hit populate, now it all goes to 1. Okay, so what effect is that going to have on the NMR? Well, first let's redo this calculation. So now we're going to recalculate the Earth model. Remember that this and the red T2LM are from the Earth model, directly from the Earth model. So let's go to this calculator and we'll recalculate the time domain first. So this just does the decay curves again. And now we go to the inversion and we will invert this. And now watch what happens. See, the red gets moved as we calculate the new T2. It updates the T2 log mean right away. And when it finishes, it will update the T2 distribution, which is actually from the NMR data, or no, it's from the Earth model, but it doesn't calculate that till this thing finishes. Okay, and Eddie, it's just about done. Tension builds. And there you go. So now you can see that we got rid of all of the hydrocarbon and we put it all into water, and you can see this funny distribution from the bimodal pore size distribution here, and the T2LM, which has now moved to be fairly uniform across this. All right, so what do we do next? So next we'll do NMR simulation, and this one we're going to call it water, and make sure that we have the time domain relaxation. Yeah, so doing this on the Earth model, and so now this will calculate a second. Oh, it's already done. And then now that we have that simulation, now we can go here and we can update these logs. But now we're going to do the same log sets, but all of them, first of all, we need to choose the water distribution. And then we're going to change each of these log sets to water as well. Didn't need to change, but here I want to select a new log set, customize it, and we'll call it W. Okay, and now let's check the Earth model. We want to make sure that we have TD selected, NMR porosity, keep everything else the same. The only difference is now we're putting it in a different log set, one that's using the water. All right, create the log sets. So now we can see that being done here. And now that that's done, you can look up here and you see that we have the same set of log sets here, but now each of them for the 100% water distributions. And so now what we can do is we'll go in here and we'll update these plots and see what effect the water has. So we might expect that the T2 is not going to be, well, it should match the Earth model because it did before, but we'll just do another one just to make sure. So we can go to the simulated, we'll go the T2 log mean water, and I'll make it this one dash dot, so it'll show up on top of the other one. And then I'll push it up. Make sure that's on top. Okay, so there you can see that the new T2L mean from the simulation matches this one. And then in the permeability, now we want to see the effect that the permeability had for these water saturated logs. And so we'll calculate simulated log, and So we want to select the water. So let's do the TC first. And yeah, okay. And so now this one shows up as orange. And you can see that this one matches in some cases on the other side, but largely a little bit closer, the same as what we had before. Our TC actually wasn't that far off. But then let's see what effect it has on the SDR. So on the SDR, we want to select the SDR permeability. I'm going to make these dash dot again, just to make sure that they look different. And I'm going to make these like a bright green so that we can see them clearly. Okay, so so this is the SDR permeability water. Oh, we forgot to do the hydrocarbon set. Okay, so that was the water set. We can see matches fairly closely now to the Earth model. And then let's unclick these and we'll do the simulated one just to see if those show any difference. So you want to pick the T2, the log mean for water. And then over here, we want to pick simulated log and we'll use the TC log mean. And then over here, we'll pick, check sim. I forgot to change the name for the Earth model one. I used sim, so I'm going to say put sim twice. Just remember that that should be Earth model. And all right, and so now we'll create that log set. So now we have the sim, and so if we go simulated, SDR permeability, water, and now if we plot the sim, something seems to be off on all of these. Oh, they all got a different scale now. Oh, because I hit the wrong. We don't want 300, we want okay, there we go. All right, just had to get the scales right. Okay, so now you can see that, let's change this to dash dot. Okay, so now you can see that these, the TC and the SDR permeability are on top of each other. And oops, this one changed to TC. Okay, so we switch back and forth on these. We can see that they're on top of each other, both the permeability and the sim, and they're both very close now to the expected Earth model. So that's how you use the NMR permeability logs and the Earth model T2LM logs. So enjoy.